All right, let's begin. So this talk is about Atomic Honeypot that drops shells. So my name is Alexander Rubin, and I have been working with MySQL, the database, for a long time. I think it's 20 years already, or coming up to 20 years. So I started at MySQL EAB, the company behind MySQL, and I was doing MySQL consulting, architecture, open source. And then 4.5 years ago, I joined Amazon Web Services as a database engineer. And I started working on MySQL, and then I switched to security. And we started doing MySQL security research, and I created a new team that didn't exist before at AWS. We call it Red Team. So currently, I'm a principal security engineer and also managing this RESEC relational security Red Team. So this is our agenda for today. We will be building an atomic honeypot for MySQL that will strike back. So we start with creating a high-interaction MySQL honeypot. Basically, the idea is to attract those bad actors who are trying to connect to your database server and see what they are up to. And then we will be using this vector that we have found called MySQL server can attack you. This is usually, people don't think about this vector. When people think about the security of MySQL, they think about server. But what if the server itself has been hacked? Now you connect to a server that you think that you own, but now it's under control of this bad actor. Now the server can actually attack you in this case. And we started with this vector, and then we converted our high-interaction MySQL honeypot to atomic honeypot. So again, what we wanted to do is we wanted to find out about the common attacks about MySQL server, and we want to interact with the attackers, and we wanted to download the code that they're using, the evil code. So, if you don't know, bots are everywhere, and they're scanning your database servers. Database servers are really under attack, especially if they are running on a well-known port. So database servers are big target. So here, our MySQL honeypot server. We start a MySQL server, and we connect it, we open it from the public internet. And the moment that you open your MySQL server or any database server from the public internet, you will start seeing connections. So people will find those servers and will try to connect to it. Those are the bots. Those are the bots that are trying to attack your server, and we are after that. So let's start with why do we need a high-interaction MySQL honeypot. MySQL protocol is a little bit different. So MySQL protocol is server-initiated. What it really means is that if you just start a TCP server on port, let's say 3306, then the client will not be able to connect because there is no prompt. So here is the example of the prompt that MySQL server is giving you. So it will give you a server version, it will give you the salt, and it will give you the plugin name. We will actually be using all of that. So just listen on a port, a TCP server is not enough. So what do we need to have to actually create a MySQL Honeypot. So the good news is that there is a very simple to use Python library that implements MySQL protocol. So it's called MySQL Mimic. So it's very easy to use, and it supports a lot of things. It supports SSL, it supports the MySQL protocol packets, and it gives you lots of control over what you can do. So we started with this, and we started with a high interaction MySQL honeypot running on a well-known server, and we start seeing people connecting, bots are connecting to us. And MySQL have these connection parameters, connection attributes, similar to HTTP user agent. So basically, you can see what client programs, which version they're using. And this is what MySQL defines. It defines client version, operating system, program, and program name, right? Platform and program name. So you know, unless people are really try to deceive you, right? You will see what kind of client programs they're using. This is the example of the bots that are being connected to us, right? We can see that they use, some of them are using Windows, some of them are using Linux. There are lots of interesting information here. So from there, we saw two major attacks on MySQL. The first one is attempts to own MySQL server, escape from the database, and create a backdoor. It's actually using a very old method, and it's unlikely that they succeed. They may succeed on some really old servers, but unlikely they succeed right now. And then the second attack is more interesting and probably a little bit more recent. So this is a ransomware attack. Those bots try to connect to your MySQL server, try to brute force the password, then downloads your data, deletes your data, and put a ransomware note to you. So we are seeing this attack, and this is the attributes, the connection attributes, the fingerprints of this attack, right? This is what we see in what they're using, and what is also interesting here, they're using mysqldump. Mysqldump is a backup program. And the reason why we are seeing mysqldump, because the whole idea of that attack is that to download your data, to drop the data, ask for ransom, and basically saying, if you will pay us, then we'll give you data back. So from there, we want to see what we can use to strike back. And we will be using this MySQL server vector. MySQL server can attack you. Those bots are using client programs, client libraries. So we control the server. We want to see what we can do to basically download the code from there and interact with them. We have been looking at 3 CVEs. The first one is MySQL client arbitrary file read. That has been known for a long time as a very old attack. The second one is client remote code execution. Again, server will make the client execute your program. And the second one is another example of remote code execution. Basically, the first one we found in 2023. We presented it at HitB that year conference. And the second one we found in 2024, and we presented it at DEF CON last year. So this presentation is similar to the one that we gave at DevCon, but it's a full version of that presentation. Let's start with a MySQL client arbitrary file read. This is basically what happens. Super simple. MySQL protocol has this load data local in file capability. Now, imagine if you connect to a server and you do your query, whatever it is, select one. Instead of this query, MySQL server will send over, give me an arbitrary file. And the client will give that file, the content of that file, back to the server. This is what it is. It's actually very old and has been fixed in all major versions now. To use that is super simple. You can just download this Python program, run that on your port, that will act as a server. Now you specify which file you want to read from the client. That's it. Now client connects, and if the client is unfixed, then the server will be able to read a file from the client. Here's the quick demo of how it works. So first, I download this Python script. Then I run it, and I specify I want to read etc password on port 336. Then I use this MySQL version. It's old version where it's not fixed. Now I connect to my server, and that's it. Password obtained. So now I read the password from the client on the server. Now, here is how it will look like if the client program is patched. So let's see. MySQL version 8. And then I will do the same thing. I will connect to my server. And the server will initiate the file read, but it will not succeed. And if we will do just select one manually on that, we'll see why. So this is the error that it will give us if MySQL client doesn't allow this load data in file. So in this case, that was fixed, and that's why our attack was not successful. The second one is even more interesting. The second one is remote code execution on the client when the client connects to a rogue server. To really understand how it works, we need to first understand the MySQL protocol. So here's how MySQL protocol works. We have MySQL client and MySQL server. And MySQL clients connect to the server and say, hello, MySQL server. Authentication, please. And I have a username and password. And by the way, I will use MySQL native plugin. So MySQL has this ability to implement any plugins. It's a pluggable authentication. So with a pluggable authentication, MySQL client can actually request which plugin it will use. In this case, it will request MySQL native password plugin. And the server will say, OK, very good. I loaded this plugin, and I checked your username and password, access granted. Now, I have another situation. So the client will say, hello, MySQL server, authentication, please, and I will use whatever plugin. And the server will say, nah, I don't have any idea of what this plugin is. Let's try another plugin. And the client will actually agree And the client will say, OK, I'll try to load another plugin if I have that. So basically, the server can change the authentication plugin on the client. So then let's look at the code. MySQL, open source. You can take a look at the code of the client library. It's actually part of the same server repository on GitHub, but it's a client library code. And then you can see this. So if you're wondering what loading the plugin is, it's deal open. So here, the plugin name comes from the server. But it also only loading the plugins from the plugin dir. This is a dedicated directory for the plugins. And that directory cannot be changed on the server. But what if we will use directory traversal? So if we'll use a directory traversal, we can tell the client to load the arbitrary shared library, right? We can load that file from any directory. And also there is another issue that will allow me to create a long string here so that it will be able to load a really arbitrary file without this extension. So this is arbitrary code execution via directory traversal. So again, how does it work? First of all, the bad actor will need to upload a shared library file. It can be any location, any file name. And then when MySQL client connects to the server will push the plugin name, and then the client will load that. So here's the quick demo of what we did. In this particular scenario, my colleague Martin sent me a resume, a PDF file. And when someone sends you a resume, what would you do? Well, you probably save it, at least. You don't need to open it. You don't need to trigger any code from it. You just save it somewhere, like documents on Mac. And then this is not a PDF file. It's actually a binary, a shared library generated from that code here. So that code creates a file on disk and also opens a calculator. This is a demonstration of the arbitrary code execution. So now let's see how it works. Our goal is to open a calculator as a demonstration, and then this is the file on disk. That's the only thing that I need. Now I start my rogue server here. And in this scenario, I'm trying to connect to my server, but it is hacked, and now it's under the control of the bad actor. So now I use MySQL Workbench. MySQL Workbench will try to connect to my hacked database. This is a really old version, 8018. Don't use that. Now, I am connecting to this my hacked database. I have my plugin directory configured here. And I just need to establish the connection, nothing else. And that's it, calculator. Right? So basically, we demonstrated that a bad actor can replace your MySQL server with this Python script and get an arbitrary code execution, a remote code execution on any client that connects to that server. So the third one is also interesting, and it's really an unusual vector. This we discovered in 2024, and released to Oracle MySQL, so they fixed that. So this CVE is in MySQL dump program. That's a backup program. And what MySQL dump is doing is it connects to your server and generates a set of statements, SQL statements. It will produce a text file. Do you think that text file can contain an exploit? And actually it is. The thing is, MySQL documentation suggests this. Basically, if you want to copy one server to another server to set up a replication or something, then you pretty much connect your MySQL dump program to your server 1 and then pipe to MySQL command line program, which will actually re-execute the statements on the server 2. Now, the thing is, MySQL command line client have this ability to execute shell commands. And because it can execute the shell commands, your rogue server can actually push anything to the client. So, what if we'll push something? MySQL actually do a good job escaping those. You basically expect a string from the server. And if it's a string, you do enclose in something. But then there's one exception. We found this code where MySQL client library, MySQL dump in this case, checks the version of the server and don't escape it. It doesn't treat it as a string. It treats it as as is. So if you will create a rogue server out of that, and then we can push the end of line and our command, then we have a command execution. So this is a single line patch to MySQL server. Any version of the server, doesn't matter. And then we can do a touch and create a new file. We can do anything else. So this is how it will work. If we start this server, and then we do a telnet to connect to that port, this is what we see. MySQL server sends the version name to the client. And now it sends the end of line and our command. Now, if you pipe that to MySQL command line client, then you will have a command execution. So here's how it will look with the MySQL dump output. And if you pipe it through MySQL command line, then we have command execution. Starting with that, we have created our atomic version of high interaction MySQL Honeypot. And we added two options here. The first option is to implement this CVE 2024 MySQL dump command injection, and the second one is the rogue MySQL plugin that we presented in 2023. And then here's our Atomic Honeypot, and our goal is to get the evil source code. Before we'll go there, I wanted to do one quick demo of how this CVE 2024 will work. And this demo is on Windows. And we will use the MySQL dump program and we'll connect to our honeypot to get the remote command execution. So here's what we'll use. We'll use this payload, Visual Basic on Windows. Basically create a window. This is our honeypot. Our honeypot will have this version string payload. And this payload will get that payload from the HTTP server. So we start HTTP server as well. Now this is our old version of MySQL dump before the fix. We run this MySQL dump, connect to the server, and that's it. So because MySQL dump have this issue, it mysqldump pipe MySQL will have that issue. It will execute the arbitrary command. Now with this honeypot, we are finally going to explore our bad actors. So we started with attack number 1. We started looking at the fingerprints that we have. And we realized that this is Windows. The client version is really, really old. So we have some chance here. But we don't see mysqldump. So the attack number 3 will not be feasible here. So we can probably read arbitrary file. We don't know if we can do a remote code execution via plugin, and there's no mysqldump. So let's start with the arbitrary file read. So our first interest were what version of Windows they're using. And there are multiple files that you can download from Windows. You can download Windows Update, basically to see what version it is. And we quickly realized this is Windows Server 2003 or Windows XP, which is really, really old. That explains why they're using that version of MySQL client. So now with that, our next goal would be to try a remote code execution. So for the remote code execution, we need to have a DLL. And this is our DLL with a payload. Again, nothing fancy, just message box. So we have been thinking, how do we push the DLL file to the attacker server? In our previous example, right, it was a resume, but here we don't know how to push. But first of all, we have started looking at the queries that those bad actors are sending to the server. And we quickly realize this is what they're doing. This is the part of the attack. They're trying to basically they try to upload their payload. And they're using FTP server. And they have an FTP server somewhere on their infrastructure. So we were thinking maybe we can just push it. We have the FTP server running. It's on the same host. We know the username and password, and maybe we can upload it to the public. So we have created this simulation. And in this simulation, we are uploading a DLL to a public location to any FTP server. Then we will run Atomic Honeypot to trigger the DLL, and then we'll get shell. So here's how our attack may have looked like. We decided not to do that in real world, but this is our simulation. Let's start it. So basically, let's imagine that we have a FTP server running, and we have this demo and demo. And then we will do put into that FTP server, into public location. We put an evil DLL, our payload. Now, what we will do is we will use this shell, honeypot, and start our honeypot. And then we will basically adapt that honeypot to load our plugin, load our DLL. We will specify the path, because we have under assumption that we uploaded it to the public directory, and then we specify that public directory, and we're trying to to launch that from the public directory, right? So now we start listening on our port. This is our payload, the DDL. We compile that DDL, and now we log in. We have our MySQL command line client for the simulation. In reality, it would have been their program. We connect using that MySQL command line program, and that's it. You have been pawned. So this is how this attack could have been executed on those bad guys. So to recap, at the example number 1, arbitrary file read was successful. RC via plugin was done via simulation. Attack number 2 is more interesting. I would say much more interesting. We started with the same thing. We captured the fingerprints. And we see here 2 things. We see a normal MySQL client, libMariaDB. MariaDB is pretty much the fork of MySQL. And we also see here mysqldump. Now, those are the recent versions of the client libraries. So we cannot do arbitrary file read, we cannot do RC via plugin, but this is our chance to actually try out the latest version of CVE on mysqldump. Now, we started by analyzing what they are doing. We control the server. That means that we see all of those queries that they run. So we can see what they're doing. They are listing the databases, listing the tables, and then for every database and for every table they find, they run mysqldump. Now, notice here limit 10. What they are doing is they are only grabbing 10 records from your tables. So they are pretending to actually downloading your database. They are not doing that for real. And if you think about that, that's logical for those bad guys not to download your database. Because if you start downloading terabytes of data, how do you store it? How do you deal with that? So instead, they're just pretending. Because if they will send you a note, a ransomware note, give me whatever number of bitcoins and I will give you the data back, you may ask, prove to me that you have my data. And they will give you 10 records on every table. So that's why they're doing this, right? But they are running mysqldump. They're running mysqldump with a limit 10. And then we were thinking, can we download the code with the arbitrary file read? No. Can we execute the plugin code with a plugin? But then we start thinking is, how this attack designed anyway? So we come up with this diagram, potential diagram of how this could have been done. There should be some application running somewhere. And from that application, they have to execute mysqldump. So if there's a CLI, it's a CLI on Linux. So they will, we know that this is Linux, right? So we know that they're doing some execution. And then the last thing is we see again the connection from the application again. So connection from the application, mysqldump suddenly, and then connection from the application again. So probably exec. And then we started experimenting with the table names and the database names. And we see that whatever table name we present on a server will come back to us as a part of that mysqldump program. So we're thinking is, if we control the database name, if we control the table name, maybe it's a command injection. And really, it was a command injection. So basically, if you create this schema name and put a command, a Linux command here, super simple, then you will get the result back. So this is how we can actually see the process list on their server. You do psax, base64, and then this is a table name will be sent over back to us as a part of the mysqldump command. And this is how we can see this. So it's actually worked. I was surprised, but this is how it worked. So we can actually see this. We can see their process list. We can see their code. And we downloaded this evil code. This is what they're doing. They are using a mass scan to scan to find MySQL and also MongoDB servers on known ports. And then they are doing a brute force, password brute forcing to connect. And with the known passwords, they connect to your server and then run this mysqldump command. So this is all written in Python. There are multiple command injections there. Command injection everywhere. So probably those guys have never did a security review of their code. So this is basically it. We were able to download, we were able to use the mysqldump CVE to download their code. So if you want to try it at home, you can also do that. You don't even need the MySQL Honeypot. You can start a normal burner MySQL database server, and then you can create your database names like this. You can do a semicolon command. You can also do this $sign in command. This is bash. It's bash, right, on Linux. So this is either of those probably work. Since the DEF CON presentation, I never touched that. I don't know if this has been fixed or not. But the mysqldump CVE was actually fixed. So this is the summary and conclusion. We have found a new CVE in mysqldump client utility. This is an unusual attack vector. You are attacking a client from the server, and in this case, a client is mysqldump, a backup program. And what will happen in this case, the payload, the evil code, is a part of the text file, a part of your mysqldump backups. Atomic Honeypot can attack and stop the attackers potentially, and the tool will be released soon. That's it. Thank you very much.